the ocean has to tell us a lot. It's not silent. It's very noisy actually, and there are many sounds from animals, of course, but also sounds from humans.
It's a cold and windy day off the coast of Brittany in France, and scientific diver Jan Fontana prepares to plunge into the chilly water. His mission? To deploy a sound recording device on the seabed. That's part of the study led by bioacoustician Lucia Diorio. Within international research projects TREK, she captures the so-called underwater soundscapes along Europe's coastlines.
Here we're listening mainly to seagrasses and kelp. They are nurseries, so the little fish and little larvae grow there. They protect from erosion. They produce oxygen, they stock carbon. They have a lot of important roles in the ecosystems.
Sound recordings, together with genetic samplings, help scientists better understand such marine biodiversity hotspots. But as we talk, several ships are passing nearby. How does such artificial noise affect the ecosystem? The diver resurfaces with another hydrophone, which has been capturing the soundscape of a kelp forest for some time. To listen to the recordings, we return to the laboratory at the Marine Research Centre, Station Biologique de Roscoff. Lucia Diorio has been listening to the ocean for over 15 years, hoping that such knowledge helps preserve delicate ecosystems. In the recordings, she finds familiar sounds, both of natural and of human origin.
In kelp forest, as it's a rocky environment, there are a lot of these snapping shrimps and these sounds. And then we heard some boom, boom, very low frequency sounds, like that one. We can listen to a few again. These are fish sounds from fish that are used for communication. And the boat traffic is going to impair the communication of animals. It's like as if you were living next to a highway or a busy road and the cars were passing all the time, so it's annoying. So it's annoying for us, but it's also annoying for the animals living in that environment.
Scientists are becoming increasingly alarmed by the underwater noise pollution. It places additional stress on marine fauna, already threatened by numerous anthropogenic impacts. Mounting evidence suggests that noise pollution can affect a wide range of sea animals and even plants. Lucia Diorio is conducting a laboratory experiment to investigate whether underwater sound can even affect phytoplankton. If these microscopic organisms are also harmed by noise, that would mean that the consequences of noise pollution can reverberate throughout the entire food web. It has long been known that underwater sounds are essential for whales and dolphins to find their way, locate food, and communicate. That's why researchers like Michel André, who leads the Laboratory of Applied Bioacoustics at the Universitat Politècnica de Catalunya, have until recently primarily focused on marine mammals. Professor André explains that research by his colleagues over the past 10 years has greatly expanded our understanding of the issue. It's now clear that the harmful effects of noise pollution in the ocean go well beyond dolphins and whales. And to effectively address this problem, we might need continuous global monitoring of underwater noise.
We discovered that other species, namely invertebrates, which are cephalopods, crustaceans, jellyfish, coral reefs, thousands and thousands of species were suffering probably more than cetaceans. And this has changed totally the way we were addressing this effect of noise in the marine environment.
Based on the findings of the European research project called LIDO, Michel André's laboratory has deployed a large network of marine acoustic stations. Human-generated noise from maritime transportation, wind farm construction, industrial or military operations creates an underwater acoustic fog that can disorient marine animals. According to Andre's concept, autonomous acoustic observatories could identify and alert the sources of noise, urging them to keep quiet.
Noise pollution is threatening the balance of the ocean, and we need to take actions to reverse these negative effects that we have introduced without even knowing that we were contaminating the ocean through sounds.
But how can we reduce the noise when global shipping is increasing? The Elbe River near the port of Hamburg in Germany is a busy shipping route, passing close to the sandbanks with a large population of seals. This proximity allows scientists to observe how these animals react to noise and suggest appropriate ways to make ships quieter. Using a radio antenna, Josef Schnitzler from the Institute for Terrestrial and Aquatic Wildlife Research locates an electronic tag in the river. This device used to be attached to one of the seals and automatically came off after some time.
Such big vessels, container ships like this, arriving every day in this port and making a lot of noise. And this is actually what we are recording with this device. A tag that was still attached to a seal a week ago.
The tag on the seal's back recorded both the seal's movements and the level of noise around it. Seals in this area rely on sound to catch prey because the visibility in the water is poor. The data from the tags shows that the seals seem to get disturbed by large ships. The noise from the propellers and engines appears to interrupt the seals' hunting and makes them dive restlessly between the riverbed and the surface. But how can we use this information to make ships quieter?
It might be a mixture of technical solutions like change of the propeller design, but can also be some functional changes like reducing the speed of vessels or rerouting of a shipping lane.
Scientists in the European project Saturn are exploring both biological and engineering aspects to help cut the noise, reducing at least one of the many harmful human impacts on the ocean.
Here we have the chance to quickly change something which is not possible actually with chemical pollution or with plastic debris and microplastic in the seas. The solutions are very near. You can grab them nearly.